The metric system we know and use today was developed in France through the growing need to standardise units of measurement. Before the French Revolution in the 1790s, approximately 800 different units of weights and measures existed in France alone, with as many as 250,000 different definitions of these, due to the varying quantities used from one town to the next. Naturally, this led to chaos. The National Assembly of France instructed the French Academy of Science to design a new system of weights and measures. This was approved by King Louis XVI before he was executed in 1793. The metre was declared as the standard unit of length, officially adopted by the French government in 1795, being phased in over several years. To promote the new unit of measurement and encourage people to make their own metre rulers, marble blocks with 1 metre, centimetre and decimetre markings were placed on public buildings around Paris. However, it wasn't until the 1840s that it became the only legal system to be used. A quick side note. A new metric calendar known as the French Republican calendar was also introduced in 1793. It consisted of 12 months of 30 days split into 3 10-day weeks, with an extra 5 complementary days at the end of each year. Interestingly, this was almost an exact copy of an ancient Egyptian calendar. Each day was also divided into 10 hours, with an hour split into 100 minutes and each minute into 100 seconds, which obviously confused people since the unit names hadn't changed. Perhaps it would have been more successful if they'd used the metric prefixes. And today, we might be referring to centi-hours and milli-hours instead of minutes and seconds. In some ways, it's a shame that it didn't take hold because, as shown in this decimal clock, time conversions to decimal form are simple. They also metricised angular measurement, defining a right angle to be 100 gradians, or grads for short. Unlike decimal time, though, grads did survive and are still used by some military organisations today, especially in France. Gradients can even be found on your calculator. Part of the attraction of the old imperial system was the easy factorisation of the defined quantities. This was partly why the general public resisted the new system and why it caused problems when people didn't understand the new units. It was about 1812 when Napoleon controversially introduced a system of customary units for everyday retail use. These customary units used the old imperial names redefined in terms of metric units. For example, a quart became a quarter of a litre, which is exactly 250 millilitres and also known as 1 metric cup. Reportedly, dishonest merchants sometimes took advantage of the resulting confusion. These new definitions have probably contributed to the variation between the quantities associated with unit names around the world today. In the USA, for example, a cup is about 240 millilitres. Originally, the metre was defined as 1/10 millionth of the distance from the North Pole to the equator on the longitude line passing through Paris, or 1/40 millionth of the Earth's circumference. However, the original definition turned out not to be accurate because of small errors in calculating the curvature of the Earth. As a result, it was 0.2 millimetres shorter than the actual distance. The formal definition was adapted over time to be much more precise. In 1889, the metre was defined as the length of a prototype metre, which was a platinum iridium bar with an X cross-section. It wasn't until 1960 that the metre was more scientifically defined, in terms of the wavelength of the orange-red line of Krypton 86 in a vacuum. Finally, in 1983, the metre was defined in terms of the distance light travels in a vacuum in less than 3 billionths of 1 second. The United States recognised and legalised the metric system in 1865. However, they did not make it mandatory, and to this day it is not generally used in day-to-day life in the United States of America. All but 3 countries in the world have adopted the metric system as the official system of measurement. The United States, Liberia and Myanmar are the only 3 countries that do not have mandatory metric laws, although policy in the United States is to adopt the metric system, with all government agencies required to do so. So what makes the metric system so special? It's all about the metric prefixes, which change the amount we have of the base unit. Prefixes are commonly used in language to alter the meaning of a word. For example, you might agree with me or disagree with me. Here the prefix dis completely reverses the meaning of the word. Historically, many prefixes have been used to change the meaning of a word or the quantity or value of a measurement. The prefix demi was in common language usage in the early 15th century with the literal meaning of 1/2 from its French roots. Of course, semi from the Latin and hemi from the Greek also mean 1/2, and all 3 versions are still in common use today, although not necessarily adhering strictly to the real meaning of 1/2. For any musicians amongst us, a beautiful example using all 3 simultaneously is hemi, demi, semiquaver. Demi and double were used as early metric prefixes, but later dropped in favour of using base 10 factors only. Other prefixes that were used historically but now discarded include hebdo, a prefix meaning 10 to the power of 7, that is, 10 million, and micri, a prefix for 10 to the power of 14. There were only 8 metric prefixes that were officially approved in 1889, consisting of 4 for whole number multiples and 4 for fractional multiples. Deca, meaning 10, hecto for 100, kilo represented 1,000, and myria meant 10,000 times the base unit. The symbols chosen to represent these prefixes were DA, H, K, and MY. For fractional multiples, or submultiples if you like, we have deci for 1/10, centi meaning 100th, milli for 1,000th, and myrio meaning 1/10,000th, providing perfect numerical symmetry with the 4 larger prefixes. Some sources state dimi instead of myrio, being an abbreviation of the 2 prefixes deci and milli. The symbols chosen were D, C, M, and MO, or DM for the demi version. These prefixes had tremendous advantages over the pre-existing units of measurement. There was no longer a need to change names or remember difficult conversion factors. You just needed to remember what the prefixes mean. There was no need to use fractions. Everything could be calculated more easily using our decimal base 10 place values. Long strings of zeros were replaced by one of the prefixes instead, and perhaps most importantly, the symbols for the prefixes would be identical throughout the world, ensuring no more confusion due to different units or different naming conventions from one country to another. For example, the meaning of 1 billion in the United States is very different to that once used in the United Kingdom and Australia. These days, to my knowledge, everyone, or almost everyone, follows the American definitions to avoid confusion. These symbols or abbreviations and their corresponding values are the key to why the entire metric system works and the basis for developing the SI units, the standard international system of units used by scientists, mathematicians and engineers the world over. There are only 7 units of measurement in the SI units, and all other units are derived from these 7. These prefixes were named from Greek and Latin numbers, and notice that all were represented by lowercase letters. In 1837, according to some sources, prefixes representing 1 million and 1 millionth were introduced. A new convention was also initiated, using capitals for large multiples and lowercase for fractional multiples. But the existing lowercase k for kilo, h for hecto, and da for deca remained, and they are still correct to this day. This is probably why you often see kilo represented, albeit incorrectly, by capital K. Further, it was also deemed only necessary to create prefixes in multiples of 1000 of the previous prefix, starting with kilo. Hence, mega with the capital symbol M became the prefix to represent 1000 kilos, which is 1 million. Similarly, micro became the prefix for 1 millionth. But there was a small hitch. Lowercase letter m was already in use for milli. Although Latin terms had been used for fractional prefixes so far, inspiration was drawn for micro from its Greek roots, meaning small, and the lowercase Greek letter mu was selected as the symbol. Of course, this created some problems, especially when Greek characters were not readily available for typewritten expressions. There is evidence that even today alternatives for micro are sometimes used, usually written as MC, MIC, or even as the letter U. With the rapid advancement of science and technology, the need for bigger and smaller prefixes continued to expand, but it wasn't until 1960 that Myria and Myrio were discarded to maintain the preferred 1000 multiple of previous prefixes, other than the smaller prefixes for tens and hundreds and the larger fractional tenths and hundredths, which were kept in place to cater for everyday situations. With Myria and Myrio gone, new prefixes were added for 1000 times mega, called giga, and 1000 times giga, to be known as tera. To balance these, we have 1 billionth, that is 1000th of the already defined micro, to be called nano, and 1000th of this to be known as pico. There was no more need for prefixes with non-Latin characters or multiple characters, so mu remains the only non-Latin character within the prefixes to this day, and deca is the only remaining one with multiple characters. All future naming would follow the new conventions, drawing inspiration for the names from combining available suitable letters with names of Greek and Latin numbers, or words of size and magnitude. At this point, the advantage of using the prefixes to replace such large numbers becomes glaringly obvious. Of course, these large values can be more concisely expressed as powers of 10, where the power conveniently matches the number of zeros we had following the 1. This is one reason why the prefixes follow our decimal place value system. A negative power means it is the fractional case. You can learn why when you study index notation, but it's easy enough to count the zeros and change the power to a negative. You might prefer to use the names for the large and small numbers created by the prefixes. But remember that the accepted versions now follow the American conventions, as discussed earlier. This list of prefixes is perhaps the most commonly taught version, and indeed has values beyond what most people need in their day-to-day lives. However, the need for larger prefixes is evident with the size of digital storage growing rapidly and already surpassing the value of 1000 terabytes. So let's round out our video by adding all the remaining prefixes. There would be 4 more occasions when the International Bureau of Weights and Measures would see fit to extend the list of prefixes. In 1964, 2 more fractional multiples were added. The new prefixes were named femto for 1000th of the previously defined pico, and 1000th of femto was to be known as atto. Following the clear conventions, lowercase f and a are the respective symbols. Then, in 1975, the prefixes peta and exa were added to balance the large values with the fractional ones. In 1991, 4 more prefixes were added. 2 for forming large multiples, zeta and iota, and their balancing counterparts for fractional multiples, zepto and yocto. The last additions to the prefixes, to date, came in 2022, when Richard J.C. Brown proposed prefixes up to the power of 30. This resulted in 4 more. Ronna and quetta for 10 to the power of 27 and 30, respectively, and ronto and quecto for their negative power equivalents. And now we see the complete current list of metric prefixes as recognised by the Bureau of Weights and Measures in January of 2025. Most school curriculums probably won't expect you to use prefixes beyond tera or nano, but once you understand how to use them, it shouldn't be too difficult to use any of them. It's probably worthwhile being familiar with pico, being the fractional equivalent of tera. And if you're into computer technology and digital storage, you'll need to know about peta. Who knows when even larger prefixes will become common usage, but remembering that each new prefix is another multiple of 1,000, or 1,000th for the fractional cases, should help you adjust quickly if and when they do become necessary. There are currently only 24 prefixes officially recognised using upper and lower case letters of the alphabet. But if we do need to extend the list further, the rest of the unused letters are either unsuitable choices, such as O, which can easily be confused for 0, or already used for units, such as W for watts. Some have suggested reintroducing combining prefixes, a practice that has been done many times in the past, but is reportedly frowned upon and not officially recognised by the International Bureau of Weights and Measures. For example, 1,000 times quetta would simply become kilo quetta, and 1,000 of those would be mega quetta, and so on. Fortunately, for the overwhelming majority, we are unlikely to ever need to work with measurements quite so big. To better understand how and when to use the different prefixes and how to change from one to another, be sure to check out the second video in the series. Thanks for watching.